Hello, my name is Juan Reyes. I am an oceanography student at the University of Texas at Tyler, and today I will be conducting a simple at-home experiment in which I will compare the freezing characteristics of fresh and salt water. I will be examining their freezing rates, as well as the texture and the appearance of the ice. For this simple experiment, I added 500 milliliters of water to both of these plastic containers. I then proceeded to add 5 tablespoons of salt to this container here on the right. So this is my saltwater bowl and this is my freshwater bowl. I will proceed to put both bowls in the freezer and check back every 25 minutes for progress. I will keep on doing this until the water in both bowls is freezed completely. After that, I will then reflect and try to connect my observations to real-life oceanography concepts, like ocean circulation and salinity. But before I begin my experiment, I want to state my initial hypothesis. It is common knowledge that the presence of salt in water retards the freezing rate. In addition, the standard freezing temperature for fresh water is 0 degrees Celsius, whereas for salt water, it is widely believed to be around -2 degrees Celsius. So while I expect the freshwater to freeze at a faster rate than the salt water, at the same time, I don't expect their freezing rates to be that far offset because their freezing temperatures are relatively close. So without further ado, let's get started. I will proceed to first place the saltwater bowl in the freezer. Now let's add the fresh water. I'm trying to be careful not to spill. So I will close the freezer and let these two bowls rest for a while, and I will check back in 25 minutes to see any progress. Another 25 minutes have passed since I last opened the freezer. In total, 200 minutes from the start of the experiment. I will now open the freezer and check the progress. Starting with our freshwater bowl here. So by the looks of it, the freshwater seems to be completely frozen at this point. It was already almost completely frozen the last time I checked it, but I can tell it's more stiff now, and I'm going to try to touch the bottom if I can. Okay, so I made a gap or a separation between the ice and the plastic container. I'm grabbing the ice right now, and yes, as you can see, it is fully frozen, fully solid, and incredibly cold to touch, and also incredibly smooth as well. I know these pockets though, I'm not sure what they are. Maybe pockets of, I mean, they're not unfrozen water because it's not moving when I shake it, but these are beneath the surface. On top of the surface is all smooth and gliding. Now let's check the saltwater bowl. Okay, to my delight, it looks like it's also completely frozen, even from the bottom. I'm going to do the same thing and try to grab the bottom of the ice sheets. Okay, so it's harder to do with the salt water, but it is doable. And this is the saltwater ice. It is practically completely frozen at this point. There is a bit of unfrozen water, a bit of drops here underneath, but overall it's completely frozen at this point. If you look at these two surfaces, you can tell an immediate difference. The ice, the freshwater ice, is clear, and as you can see, it's glidey and smooth. The saltwater ice, on the other hand, is not that clear. It is a bit grayish, and as you can see here by the lighting, it is relatively rough and granular when you rub your hand across it. There's a lot of bumps, and the surface is not really uniform as well. One other thing to note is that the freshwater ice is really stiff. I can press this as much as I want without fear of breaking it. But the saltwater ice is not, that's not the same case here. If I press on it too much, it will start to brittle, to break. And so the saltwater ice is not as stiff, and it is far more brittle than the freshwater ice. And that pretty much sums up all my observations.